Hey guys, welcome back. We're going to discuss real quick the sliding decimal method for unit conversions. The sliding decimal for manipulating metric prefixes. So before we get started, we need to first get a good understanding of what the metric prefixes are. So for our class and our purposes, we are only going to go from milli to kilo. That's a total range of 6 decimal places. If you don't believe me, we have to first understand what these exponents mean. It's short and simple that the decimal place 10 to the 0 is telling me how many decimal places my decimal will move if my number is 1.0. So if it's 1.0 and it's raised to the 10 power, it's going to move 0 places. So that leaves it as 1.0. I think that's pretty easy to understand. Let's look at the opposite end of the range that we care about today. So if it's 10 to the third, that means I'm taking 1.0 and I'm moving the decimal bigger to the right 3 places. Okay? So just keep notes. If you're going to the large exponent, you're going to the right. So it's going to be 1, 2, 3. So that's 1,000. Now I want to make sure you understand this. What this is saying is that if I have 1 kilometer, 1 km of something, that's going to make it 1,000 meters, because that's what that exponent is. So 1 km is 10 to the 3 meters. Let's do a couple practice problems, or actually before we do that, let's go ahead and look at the rest of the chart here. So this is going to be 1, so we understand it's going to be the km, it's going to be the 1000 mark. Come all the way down here to the 10 to the negative 3, the mm, which is 10 to the negative 3, that's 10 to the positive 3. What's that one going to be? That one's going to be 1.0, and I'm going to move it to the left 3 places. 1, 2, 3. That's going to be 3 decimal places there. So I am going from a range of, let me erase this real quick. I'm going from a range of 1,000 to 0.001. How big or what size difference is that going to be? Let's go ahead and actually divide those two numbers and see what we get. So come over here to our calculator. We're going to go 1,000 divided by 0.001. It's going to be 1 million. That's how many exponents we have a difference of. It's going to be, and if you don't believe me, let's look over here. I'm going to go 10 to the 10, 1 decimal place over here. I'm counting up decimal places, so that's going to be, starting from here, go 1, 2, 3, 4, 5, 6 decimal places moved over. Well, what is that? That's 6 zeros. That's a million. That's a million right there. Okay, let's do some more sample conversions, and then we'll be done with this example. I don't want to make this too long. So let's do a problem. If I have 926 decimeters, or let's go decimeters. The D decimeters. You note it, and I want to convert that into actual meters. How big am I going to be? Okay, or how small, or whatever happens. First, we have to recognize what a deci is and what the meter is. You notice there's no prefix in front of that meter. That means it's the standard. It's 10 to the 0. And the deci tells me where I'm going. So I'm going to this right here, 10 to the negative 1. So if we look, I'm going from negative 1 to 0. That's a change, total decimal place of change of 1. Now, how do we incorporate that into our problem? I want you to notice this part. What you need to understand is that the metric conversions is like a scale. It's a balance. Okay, so I have my little balance here, with my little pans here, and it's a scale. If I want to keep it even, if I increase one, the other one has to decrease at the same to keep it even. Okay, guys? So they have to maintain. It's got to be evened up. Okay. So if I am making my unit here at decimeters, if I'm going to go bigger here, because which is bigger, a deci or a standard? Well, the deci is smaller, so I'm going bigger. I'm getting bigger right here. And I want to keep my number the same. I want to keep the value of my number the same, so I have to make this number smaller. You understand? It has to be smaller. If you don't understand that, think about it as money. If I have 100 cents, and I want to go into a dollar. My unit here is actually getting bigger. Okay? It's getting bigger. That means my number here has to get smaller to keep that same value. So 100 cents is actually $1. My unit got bigger, my number got smaller. Same thing over here. If my unit gets bigger here, my number value has to get smaller, so that way I can keep it the same ratio. But how does it get smaller? Let's look. Our number that we have here is 926. 926. What that is saying is 926 point. That's our decimal place. And I want my number to get smaller. Smaller by how? Smaller by 1 decimal place, because it's deci, then your standard. So I make it smaller to the left by 1 decimal place. So my answer is going to be 92.6 meters. Now I want you to understand, these two values are the exact same thing. They equal each other. If I was going to build a house and I said, hey, you need to cut that the length of your floor, the length of your building needs to be 926 decimeters. What I'm saying is it needs to be 92.6 meters. If you said, oh, so 92.6 meters, I would say, absolutely. I'm glad you understand me. I'm glad we're working on the same level here. Let's do another example. So imagine now that we're going to crank it up just a little bit more difficulty. So if I have let's say someone's trying to add, if I have 460 millimeters, this is milli. You see over here, if you don't know these yet, if you don't know these 6 yet, you need to memorize them. That prefix is telling me which exponent it is. This is my base unit, millimeters. You know what? Let's forget that. Okay, let's not call it millimeters. Let's call it milliseconds. So that way you can see that this is my base unit, and this is my prefix right here. Okay, and this is telling me how many of my seconds it is, or what the size. So if I have 460 milliseconds on one finding, and I want to add it to 14 seconds, how many total seconds will I have? Okay, that's my question. How do I solve this? So is my answer going to be 460 plus 14? Is that my answer? Absolutely not. Here's my warning to you guys. You absolutely cannot add numbers if they are not in the same unit. Make that clear. You cannot add 460 milliseconds in 14 seconds. They are not equal, so you have to convert one of them to the other unit. And since I wanted my answer in seconds, you're going to convert the milliseconds into seconds first. So let's get to it. So the numbers that we have in mind, I'm going to add over here 460 milliseconds plus 14 seconds. And I want my answer to be in seconds. So am I going to change my seconds over here? No, I'm not. I'm going to keep them as seconds. So what I'm going to do is I have to convert my milliseconds. So I have 460 milliseconds, and I want to convert that into seconds. Is my unit getting bigger or is it getting smaller? Well, here's a standard. See, there's no prefix there, so the unit from milli to a regular second, it's getting bigger. This number is getting bigger. So what does my number have to get over here? What does that have to go into? That is going to get smaller. So how do I do that? Well, it's 460.0, and I got to move my decimal smaller 3. How many places? Well, I'm going 1, 2, 3. 10 to the negative 3 versus 10 to the 0. How many places is that? Well, that's a total difference on a number line of 3. So I'm going to move my decimal 3 places. 1, 2, 3. 3 places. So my new number, and now it's in a new unit, is 0.460 seconds. That's my new number. So I can now come over here. And add 0.460 plus that's in seconds now, right? That's my new unit, plus 14.0 seconds. And that's going to get me with a final answer of 14.460 seconds. Okay, what we just did there was converted our units, one of them to the same unit. You need to be able to do that. If you had trouble with this, I'm going to do one more problem, and then the video is going to be done, and go back and rewatch it, and then come up with your own sample problems. It doesn't do any good for you to watch this video and not try any of your own sample problems. So, one more sample problem. I want to add. Let's go into. Let's make it into liters. Say I got a big tub here, and it's measured in 532 liters. And I got a graduated cylinder here, a little tiny graduated cylinder here, and it's filled up to there. And let's call that 120 centiliters. You see what we did here? We have a centiliter and a regular liter. I want to know the volume in liters. So what do I need to do? Do I need to change my number over here, the 532 liters? No, because it's already in the unit I want. I need to change this 120 centiliters. So what do? Let's go ahead and do the problem. I've got 120 centiliters. I want to change my unit into liters. So is my unit getting bigger or is it getting smaller? My unit here is getting bigger. So what do I need to do? I need to make my number smaller. So what number is that going to be? Well, I don't know. I'd have to figure out by what unit I need to change it to. So first you got to find centiliter. Centi is 10 to the negative 2. I want to get it into my standard liter. You know this because it's no prefix, but I know my standard is 10 to the 0. How many decimal places on a number line would that be? Or how many places on a number line? Well, 1, 2 places on a number line. Well, I can do that just by seeing here's how many does it take to get to 0? That takes 2 places. So I'm going to take my decimal place right here at 120 and I'm going to move it over 2 places. I'm going to move it over 1 place and 2 place. That makes my answer going to be 1.2 liters. Now I can add my numbers up, can't I? So I'll come over here, and my numbers were 532 liters plus 1.2 liters. That's going to give me 533.2 liters. Okay, I hope that video was helpful today. If you have any other questions, you know to come get help and see me after school.